In a previous episode, we built one of my all-time favorite circuits to build whenever I'm learning something new, and that is we built a half adder. And I was really happy with how it turned out. We built it out of 4 6AU6 pentodes. But a half adder is, well, it's only half of the story. all right, that's the best it'll ever be. But a half adder is actually only half of the story. In order to get the full story, we need to build a full adder. And so that's what I want to build today. So let's hop over to the bench and take a look at how we're going to take the knowledge and circuit that we built with the half adder and see how we can expand that into a full adder. So let's hop over there and get started. So this is the half adder that we ended up building last time. You can see this is the truth table for it over here. And essentially it takes 2 inputs and ends up giving us a 2-digit binary output, essentially a sum and a carry out. And we do that with just 4 logic gates. We have 2 NORs, a NAND, and an inverter. And that NAND and inverter combo actually ends up making an AND gate. So in order to make a full adder, we really just need 2 half adders. So that's what we have down here on the bottom side. And you can see here, this is the truth table for it, and it's actually slightly incomplete. I've only got 7 of the possible 8 states here. The 8th state is just 0, 0, 0, and then the carry out and the sum are obviously 0 and 0. I didn't write it because I did poor planning and I ran out of space on the bottom here. But it's also the most obvious state, so it doesn't necessarily need to be written. And then you can see here that we have essentially 3 inputs now. We have our 2 operands, A and B, and then we have a carry in. And this is the primary difference between a half adder and a full adder, is that a full adder can use the carry out from a previous stage as an input to give us a proper 2-bit binary answer here. And so you can see that this is literally just 2 half adders. You can see here's 1 half adder here, and then here's another half adder here. And we have an additional OR gate up here that takes the carry out output of both of the half adders and ORs them together. And so you can see on the truth table here, the first 3 states here are really pretty much the exact same as the half adder up here. It gets interesting when we have 3 inputs coming on here, and one of them is always on. And you can see that ultimately we end up, if all 3 inputs are on, we have our carry out and our sum as on as well. So this is probably the most fundamental circuit in computing, and we're building it in a slightly interesting way with NORs, NANDs, and inverters, but this is actually quite buildable. So you can see that we actually have 9 total logic gates, but this OR gate can actually just be made with 2 diodes. So as far as what we need to build out of vacuum tubes, we really only have to build 8 logic gates out of tubes. And with the half adder, when we built it, we used 4 6AU6 pentodes. But I don't want to use 8 6AU6 pentodes for this. And actually, I think we can stuff it all into 4 dual triodes, because we can use each triode within the tube as an individual logic gate. So let's take a look at the schematic for that and see what that looks like. So this is the schematic that we're going to end up trying to build today. It looks absolutely mental, but it's really just split up into 4 separate parts. And so you can see that we have 2 triodes drawn here, and so these 2 triodes are going to be one of the dual triode tubes that we're going to use. And then, that's tube number 2, and that's tube number 3, and then tube number 4. So you can see here, this is our first NOR gate here, and this is the 4th NOR gate of the half adder, and then this is the NAND gate, and then down here is the inverter for that NAND gate. And you can see that our NAND gate has this interesting resistor diode set up here, and I didn't draw it here, I forgot to. There's 2 22,000 ohm resistors I'm using off of our inputs into here, and I just forgot to draw them. And then the right half of that is pretty much the exact same as the left half here. And, we have a NOR gate, a NAND gate, and an inverter to make a combined AND gate. And then the 2 carry out outputs that go through an OR gate are just these 2 little diodes here. That's going to be our OR gate to our carry out output here. And then, the sum comes off of this 4th and final NOR gate right here. So it's pretty mental looking, but once you break it down into its individual components, it's pretty easy to see what's going on. And pretty much all the tubes are set up like inverting amplifiers. You can see we have a 10,000 ohm plate resistor, 4.7 thousand ohm grid resistor, then a 33,000 ohm to -12, and a 22,000 ohm that goes to our input. And you know, the two NOR gates are set up exactly the same, as well as the inverter. And that's the same for these three as well. The only outlier is the NAND gate. It still uses a 10,000 ohm plate resistor, but the setup off of the 4.7 thousand ohm grid resistor here is a little different, because we've got these two diodes with 33,000 ohms to -12, and then 22,000 ohms to our input, and then we have a rather big 220,000 ohm to 24 volts as a pull-up for when we block the -12 volts here. And so I think we can stuff all of this onto a single breadboard. We'll certainly give it the old college try. So let's pull that breadboard out and get started. Okay, we have our breadboard set up here, and you can see I've already got jumpers set up for the 4 individual tubes right along here. And they're actually 9-pin tubes, but the 9th pin is just an internal shield, so I'm not actually connecting it to anything. So there's some very basic setup that we can do for all 8 of the triodes that we're going to be using. So we'll go ahead and do that first, and that is that each triode uses a 10,000 ohm resistor on the plate, and the cathode is connected to ground. So we'll go ahead and just hook that up for each triode here. And then we'll run little jumpers to pull the cathode to ground for each triode. And then just like before, since all 4 tubes are the same type of tube, I want to run the heaters in series. So that way there's a 6-volt drop across each tube, and we have 24 volts on our main rail here. So these 2 rails here will be 24 volts and ground, and then the ground rail on this 3rd extra piece here will be our -12 volts. So to run the heaters in series, we'll just go ahead and hook those up. All right, and so we have 24 volts coming into pin 3 of this tube, and then out of pin 4, we run right on down the line into pin 3, then pin 4, then pin 3, 4, all the way down to the end. So each heater is in series. So that's the basic setup done. So now I just kind of want to work from left to right, setting it up as we go. And the first thing that I'm going to start with is actually our buttons for input. So I'm going to put one button here, one button right next to it, and well, I'm out of space, so we'll put the 3rd button kind of down here or so. And then coming into all 3 of these buttons, we have 24 volts, and so we need to run little jumpers off of 24 volts into the button. So do that one there, and a little jumper there. So these top 2 buttons go in 2 different directions. So if we remember our schematic, they go to the first NOR gate, which will be here, and then they go to the NAND gate, which is actually going to be all the way over here. So I need to get the output from these buttons over to here. So I've got some jumpers for that. And then this 3rd button ends up going all the way over to our 5th NOR gate and our 2nd NAND gate. So it has a long ways to travel. So I need to, let's just go ahead and run the jumpers for that. All right, so we've got some basic setup going on. Let's go ahead and get this first NOR gate set up. And it's going to get its 2 inputs through 2 diodes from these 2 buttons. And then coming out of those 2 diodes, we go through a 22,000 ohm resistor. And then coming out of that 22,000 ohm resistor, we go in 2 directions. One is through a 33,000 ohm resistor to -12, and the other is through a 4.7 thousand ohm resistor into the grid. And that's the first NOR gate set up. Now the output of this NOR gate is in kind of an inconvenient spot. And the output of that NOR gate needs to go to the input of the 2nd NOR gate. So let's go ahead and take that output and move it to this dead space in between the 2 triodes here. And we'll just do that with this little jumper right here. Okay, and then coming off of that jumper, we're going to go all the way over to this other side over here so that we can then use it as an input for our 2nd NOR gate right here. And that being an input means that it goes through a 22,000 ohm resistor, which we'll just put in right like this. There we go. And then on the other side of that 22,000 ohm resistor, we go through a 33,000 ohm resistor to -12. So we'll hook that one up like that. And a 4.7 thousand ohm resistor into the grid, which we will just squeeze right in there like that. Now the other input into this final NOR gate here comes from the inverter all the way over here. So we need to run a jumper to get that input all the way over to there. There we go. And we'll finalize that input coming out of this inverter when we get over to that section. Now the output from this NOR gate goes in two directions. It goes to this NOR gate as well as to this NAND gate. So we need to find a way to get this output all the way over to there. So we're going to need a quite long jumper for that. Okay, so that can be the input into this NOR gate, but it also needs to get over here to this NAND gate. So we need one more jumper to run it all the way over to there. There we go. I think we're dodging everything in there. I don't know, this could end up being a disaster piece. We'll see. It's already an organizational nightmare for sure. All right, so that's our first dual triode and our input mostly taken care of. So let's move over to our second dual triode here. Now the first triode of our second tube here is actually a NAND gate. And this one is a little more complex to set up because we have a 4.7 thousand ohm resistor coming off of the grid, and then we have 2 diodes and 4 resistors that we have to take care of. So let's go ahead and put that 4.7 thousand ohm resistor in. Now to get our 2 diodes in, we'll go ahead and put one like that. And then we'll put the second one in the spot next to it. So that's our 2 diodes, which are connected to this pin of the 4.7 thousand ohm, but we also need a 220,000 ohm as a pull-up off of that. So we'll go ahead and run that one as well. It's going to slip right in between them there. And then coming off of these 2 diodes, we go in 2 directions yet again. We go through 2 33,000 ohm resistors to -12. And then we go through 2 22,000 ohm resistors to the inputs from our buttons, which we can see are up here. So we plan that out all right. That hooks up just like that. So there we go. We've got our 2 buttons coming in, straddling our series connection here, and then going through these 2 22,000 ohm resistors into our diodes here. And also we have the 33,000 ohm to -12, and we have a 4.7 thousand ohm to the grid, and a 220,000 ohm as a pull-up. So I think that's all hooked up pretty correctly. Now the output from this NAND gate goes directly into the inverter that's next to it. But you can see we're pretty much out of room. So it goes through a 22,000 ohm resistor. So I think what I'm going to do is I'm going to run a 22,000 ohm resistor from this first pin into this open dead spot in between the 2. So we'll just run that 22,000 ohm resistor just like that. Okay, and then to get that on over so we can use it, we'll just use a little jumper here to just kind of move it over to the other side there. And then that goes through a 4.7 thousand ohm resistor into the grid. So we'll just go ahead and run that one in like that. All right, and so that's the output of our NAND gate coming over through a 4.7 thousand ohm resistor into the grid. And we have our 22,000 ohm resistor here. So all we're missing now is just that 33,000 ohm to -12 volts. So let's go ahead and hook that one up. Now we do have a new problem in that I need to get the output of this inverter to someplace that I can use it. And I'm kind of all out of room. So I'm going to pull this little 4.7 thousand ohm resistor out. And I'm going to run a little jumper to move that over to a place where I can use it. Okay, and then that output out of that inverter goes in 2 different directions. One is all the way out through a little OR gate as our final output, and the other one is back over to this NOR gate right here. And remember, we ran this orange jumper here as our second input into this NOR gate. So I just need to get a little diode from this output here to that input. We'll just pop a little diode in there like that. Now this other output needs to go through a diode and then ultimately to an LED for our indication. So I'm going to put that LED all the way over here on the end. So I need to get this output all the way over to here. So I've got this quiet long jumper that I'm going to run here. Okay, and then we'll figure out that dual diode OR gate here in our LED when we get to that end of the board. All right, so now we essentially do this again over here. So we've got our two inputs coming from this yellow wire and this yellow wire to our first NOR gate here. So we just need two diodes to bring that over here where we can use it. Okay, and then coming out of those two diodes, we go through a 22,000 ohm resistor. And then on the other side of that 22,000 ohm resistor, we go through a 33,000 ohm to -12. And then a 4.7 thousand ohm into the grid. Okay, and then we've got our short little brown jumper to scoot the output of this NOR gate into that dead space in between the two. And then like before, we've got that output going through kind of a long diode here to get it all the way over to the other side. And then the grid goes through a 4.7 thousand ohm resistor. And we got to make sure that that diode doesn't touch this edge of the resistor here. So it's a tight fit, but I think we've got enough space between it. And then we've got off of the edge of that 4.7 thousand ohm, we've got a 33,000 ohm to -12 volts. And then a 22,000 ohm that connects that long diode up to that 4.7 thousand ohm. So that'll go there. Now we do need one more diode and one more input, and like before we're going to use a little orange jumper shaped like a U to bring that over to here. Oh, and I've forgotten that I also need a jumper to move the output off of our plate. So I'm going to pull this 22,000 ohm and this 4.7 thousand ohm back out again, and then run the jumper for our plate here. There it goes. And then we'll put that 4.7 thousand ohm and 22,000 ohm back in. Okay, and then so this output that we ran right through here is actually the output from our fourth NOR gate. So that actually just needs to go to an LED. So we're going to go ahead and just run a 22,000 ohm resistor off of that, just like that. And then here is our LED. And then we're going to run a little 10,000 ohm resistor in parallel with the LED to make kind of a voltage divider going on here. And that's just to shift the voltage level to something that doesn't destroy our LED here. Okay, and then next we'll go ahead and start on this NAND gate. And it's actually just the setup exactly the same as this NAND gate over here. So I'll start with a 4.7 thousand ohm resistor off of the grid. All right, and then coming off of that 4.7 thousand ohm resistor, we have two diodes. And also coming off that 4.7 thousand ohm resistor, we have a 220,000 ohm resistor as our pull-up. And then coming off of the other side of those diodes, we have two 33,000 ohms that go to -12 volts. And then we also have two 22,000 ohm resistors going in the other direction. And that hooks up to the two inputs that are these two gray jumpers that we installed earlier. All right, and then the output of that NAND gate goes through a 22,000 ohm resistor, and we're going to just run that right into the dead space in between here, this little open spot right here. And then we'll use a jumper to relocate it a little further out to make it a little easier to deal with. All right, and then this final triode over here is the inverter to make that NAND gate be an AND gate. So we need one diode coming off of that. That's going to be the output, actually. And that's coming off of the plate into this orange wire here that comes all the way over here to an input for our final NOR gate over here. And then we just have a 4.7 thousand ohm resistor connecting up to that jumper from the plate of the previous triode. Although I just noticed that this ground wire is actually hooked up in the wrong spot. That could have been an issue. There we go. And then we can run this 33,000 ohm to -12. Well, the output of this final inverter, which is our AND gate, also needs to go out and OR into the output from the other inverter AND gate. So I need to pull this 4.7 thousand ohm out right quick and use a little jumper to get the plate out to some place where I can actually use it. All right, and then we'll put that 4.7 thousand ohm back in. Okay, all right. And then this little orange jumper we just put in and this yellow jumper that comes from way over there need to go through two diodes to OR together to be our output. So we'll just run two little diodes off of that. And then that just needs to go to an LED. And so that goes through a little 22,000 ohm resistor. And that goes to an LED like that. And then we have a 10,000 ohm resistor that goes just on the other side of it like so. Okay, so it looks like everything's hooked up correctly. I mean, I would like to say that it all looks correct to me, but it's pure and utter chaos. And so the best way to tell is to just put our tubes in and turn it on and hope for the best. So let's go ahead and plug our 4 6DJ8 vacuum tubes in. All right, now all we're missing is 24 volts ground and negative 12 volts. So we'll go ahead and see if we can find a place to plug those in here. So there's 24 volts. There's our negative 12 volts. And then there's our ground. All right, moment of truth, I guess. We'll just flip the switch and see what happens. Hopefully we don't let any magic smoke out. Okay, both the LEDs came on. Now, as the tubes warm up and start conducting, both LEDs should fade out and turn off. Okay, one of them turned off. All right, there goes the other one. That's good news. Neither of them are coming back on. All right, well, if we look at the truth table, if I push one button, it doesn't matter which one, any one of these three, we should get one of the LEDs lighting up. So let's give that a shot and see what happens. All right, that's good. That one lit up. Let's push that one, okay. Okay, so we know that it's partially working. Let's push 2 buttons. Now, any 2 buttons should make the other LED come on. So there's 1 button. There's 2 buttons. All right, that's good. There's 1 button. There's, uh-oh. That didn't work. Okay. Okay, so we've got some work there, but that doesn't work. Now what happens if we push all 3 buttons? Yeah, we've got a problem somewhere. Okay, let's troubleshoot. I kind of figured that we'd have a problem. I guess I'm gonna need to troubleshoot it a little bit. Okay, I was poring over this thing, testing here and there, and I was trying to figure out what was going on. And the issue was that the NAND gate was never outputting a proper logic high. It was only going up to about 9 volts, which at logic high, it needs to be up around 20. And I couldn't figure it out. And I think I've got it. I was poring over the resistors, and it comes down to this. These 2 resistors, one of these is red, red, orange, which is what I want, that's 22,000. The other one is orange, orange, red, which is 3.3 thousand. And I was using the orange, orange, red. Somewhere along the line, I got my resistors mixed up. So let's go ahead and plug the proper 22,000 ohm resistor in. And in my troubleshooting, I removed the diode coming off of the inverter here. So we'll go ahead and just install that there. Well, I think that should fix it. So let's flip the switch back on. Both LEDs come on. Now as the tubes warm up, they should dim out and go off. There went one. There went the other. Okay, so hopefully we're working. Oh, I gotta hook this jumper up over here. Let me hook that up right quick. Now I was poking around this, so hopefully it's working now. So let's give it a shot. Yeah, okay, okay, so we're back to where we were. Now let's push these 2 buttons. Yeah, that's good. That's good. Now here's where the problem was. If I pushed both of these buttons, we should get this LED illuminating. There's 1, there's 2. Yes, yes. Thank you. Thank you, oh Lord of resistors, thank you. All right, so if we push those 2, if we push those 2, or if we push those 2, we get that far LED illuminating. So the only thing left to do is to push all 3 buttons, and if we push all 3, both LEDs should come on. Yes! Yay! Hooray! All right, there we go. It works! Hooray! So we have a functioning 1-bit full adder made out of 4 6DJ8 vacuum tubes. This is just super, super cool. I am super happy now that it's working. I mean, I think it's nice to have some 3.3 thousand ohm resistors hanging around, but I think I'm gonna throw this one in the trash out of spite. So now that it's functioning properly, I am just stoked. It looks like absolute madness across it, but everything's plugged in, everything seems to be working. And so we have a fully functional 1-bit full adder. That's awesome. It's so exciting. So I hope you guys were able to follow along with my organizational nightmare here, but I had a lot of fun figuring it out, minus the 3.3 thousand ohm debacle. And it works, which is awesome. So I'm going to keep messing around with this, and maybe we can figure out how to expand this in the future. But for now, thanks for watching, and we'll see y'all in the next episode.